Solar trigeneration is an electrical and computer engineering project at San Diego State University. This project stems from an issue our sponsor, Enersion, has. Enersion is a clean energy startup with a system called trigeneration, where they provide cooling, heating, and electricity to a customer. To assist their analysis, we created a graphical user interface that displays input data such as solar availability, electrical and hot water usage, cooling load, and compares it with the project's projected energy capabilities of various sizes of Enersion system. Ultimately, a cost of energy upkeep and carbon footprint analysis is to help a customer realize the benefits of installing an Enersion system. Here is the graphical user interface Team Solar Trigeneration created. To begin using this graphical user interface, the user must first format their files for cooling demand, hot water demand, and electricity demand, such that the data for each file is in hourly timestamps. Once this is done, the user can upload the data files with their corresponding buttons as shown here. The light changes from red to green when a file is successfully uploaded. The CAISO total demand, CO2 emissions, and rates files will all be provided with the graphical user interface to save time for the customer. Following this, the user will enter the zip code of the location of the building and the year corresponding to their data so the built-in API can retrieve the solar radiation and temperature data for the corresponding zip code. The user is now able to enter the number of panels they would like to install in their building. Note, a building's available roof space must be calculated beforehand to know the max number of panels able to be installed on a building. The Enersion system is configured for 1.98 meters squared panels, so the value for the size of the panels is initialized to this value. The yearly data is then displayed on the graph in the middle of the screen. There are tabs corresponding to each of the GUI's most crucial components: outside temperature, solar radiation, electrical demand, cooling demand, hot water demand, cost, and CO2 emissions. Shown here is the outside temperature of zip code 92182 for the year of 2019. In the bottom left, there is a date picker that allows the user to select any range of time within the uploaded dataset to see the data in. Furthermore, there is an interval selector that allows the user to select if they want hourly, 8-hourly, daily, or monthly running average of all the data and display the output on the GUI. Other than the graphical output, the annual energy usage in electricity, cooling, heating, cost, and CO2 produced is displayed on the right, without trigeneration, with trigeneration, and the difference that installing trigeneration will bring about for a building. All of this is possible due to our data processing algorithms that are shown in the next few slides. If you're interested more about our algorithm, feel free to pause the video.